Hello friends, now I'm going to just write the push function and the pop function of the stack. These are the primitive operations performed on stack. So I will write the push function first, followed by the pop function, and make you understand what is the underlying concept in both of those functions. So let's get started with writing the push function first in order to implement the insertion operation in the stack, that is the push operation in the stack. So I will just maintain some concept of my logic and make you understand what logic I am applying. First, let me write the piece of code first, and let me explain it to you afterwards. So I will write like this. Int push int a stack star s. So what I have written over here, let me explain a little bit of that. Int is the return type, push is the function name. This is one argument, this is the second argument, this argument is an integer argument, and this argument is a pointer argument, that is a stack pointer. We have taken a stack pointer over here. So what is the stack pointer? We have discussed this data structure of stack in my previous video pertaining to this stack. And in that we have taken a stack data structure, we have written a stack data structure, and stack data structure will be helping us over here to take a pointer to that stack data structure, and I have taken a pointer S, which is a pointer to a stack data structure, which we explained in the previous video. So you can just refer to the previous video in order to get this thing clear. So the stack star S is nothing but, stack is the user defined data type, the star means this pointer, and S is the pointer variable. So this S is nothing but a pointer to a user defined data type, that is the stack. Just as we write in the case of, suppose, int star a, if we would have written int star a, it would have meant that a is a pointer to an integer. Likewise, if we have written char star c, that would have been a pointer to a character data type. And likewise here, S is nothing but a pointer to a stack data type, and stack data type is not a built-in data type, it has been created by the user. So it is a user-defined data type, and we have explained how to define that stack data structure in the previous video. So you can just, I will just recommend you to refer to that video in order to get this thing totally clear. So now we have taken two arguments, int a, stack star s. Now we are going to push. Elements in the stack. Suppose the stack is like this. So if the stack is like this, and the stack may contain up to, suppose it can contain 1000 elements. So 0, 1, 2, 3, this is a break over here. That means there are many other positions in between. So this will be 998 and this will be 999. So this is the topmost position which we can achieve in this stack, because it is a static memory allocation, that is, we are using array over here. So first, in order to see whether we can push any element at all, we can push any element in the stack is to be determined by seeing that whether the stack is totally full, that is, the stack is full up to the brim, like a glass full of water, that is, water up to the brim of the glass. So if we see that this stack is totally full and the topmost element lies over here, then we cannot push any element further into the stack, because the stack will then overflow. So a stack overflow error will occur. in that situation, to deal with that situation, we will just put a check by means of an if-else construct, very simple if-else construct, in order to check whether the stack is full. And if the stack is full, we cannot insert, and if the stack is not full, we can insert or push one element at least into the stack. So in that case, I have just resorted to a logic that if the operation of push, that is the push operation is successful, if the push operation is successful, I am going to return a value that is 1 for success, and that will be returned to the calling module of this function from where the function is being called. And if we are getting a failure in this push operation, we are going to return 0. So if we get a 0 from this function as a return value, we can easily conclude in that case that the operation is not successful, it is a failure operation. And if we get a 1 out of this function as a return value, we will conclude or infer that the operation of the push operation has been successful. So in order to maintain that logic, I will write a small piece of code and make you understand what I have written. So let me first write that. To check whether the stack is full and whether we can at all push any element, at least one element into the stack, we have to write like this. If S is the stack pointer, so S arrow top. If S arrow top equals 999 in our case, because we have declared the stack in the previous video, so it is nothing but a continuation of the previous video. So in that case, we have taken the array to have to contain 1000 positions. So the maximum top which we can achieve is 999. So if S arrow top is equal to the S arrow top equals 999, so if the top resides over here, that means the stack is full. In that case, we will not be able to push any value into the stacks. In that case, I will get a return value of 0 to denote that the operation is unsuccessful. So let us just give a message over here in order to make you understand it more easily. So let me write like this. If S arrow top is equal to 999, printf new line stack is full, and then we return the 0 after, after that. If this is not the case, that is, if any one space is at least vacant in the stack from the top, we can insert one element. If several places are vacant from the top, we can insert several elements. So in that case, we will write like this. So if this is not the case, the program will execute in this manner. Suppose I will write like this. S arrow, array name was A, S arrow plus plus S arrow top. S arrow A, third bracket plus plus S arrow top. I'm going to explain it to you what I have written, is equal to whatever is the given in the first argument, A. So this is the operation. This is the operation of the push operation when it is done in a successful manner. So what I have done over here? Suppose write a bracket over here. So this means S arrow A means S is the stack pointer which can refer to either the array A or the integer element top. So this S arrow A means it is referring to the array in the stack data structure. This plus before this S arrow top means we are performing the pre-increment operation, because in order to push an element we have to pre-increment the top. So we are pre-incrementing the top, that is, previously we are incrementing the top first, creating a position and then inserting whatever is to be inserted into the stack. So this is the new item which is to be inserted into the stack. So since this A is being inserted successfully in the stack, we have done a successful operation and hence we will return the value of 1. So we will return 1 from here, and this brings us to the end of this function. So it is a fairly simple small piece of code, but it has a logic which needs to be kept in mind. So this is the operation of push or the push function. So we will just get on with the pop function afterwards. So if you have any doubts, you can post your comments in the comment section below so that I can address those comments. So if you have any doubts or queries pertaining to this, you can well post your doubts and queries into the comment section below so that I can address them. Thanks for watching my video.